We start a new chapter today, and basically it's about doing experiments. So section 1 goes over the steps to perform what's called a significance test. I'll let you read this. Basically, we're going to try to make some hypothesis about a population based on some sample we have. And we have several tests for it. Make some assumptions. We have a hypothesis, we have a test statistics, we have what's called a p-value, that's a probability value, and then we draw some conclusion. The significance test assumes the data production uses randomization. So, talking your sample was actually a simple random sample or something like that. And we talked about the assumptions on the sample size so we can consider whether it's a normal distribution or not. And that's where the assumptions about the shape also are in there. So we have two hypotheses, and here the terminology is key. We have what's called the null hypothesis. That's a statement that the parameter of the population takes a particular value. It always has a single parameter value. The alternative hypothesis says it falls in some other range of value. So that range will usually be greater than or less than, or not equal to. So H sub naught means null hypothesis. H sub A means alternative hypothesis. So the alternative one should express what you're hoping to show as a researcher. And you do these hypotheses before looking at the data. In other words, we don't make the hypothesis fit the data. We make a hypothesis, gather data, and then see how it lets us draw a conclusion or not. So the null hypothesis is there's no effect. So we're going to get to specifics on that too. So our test statistics is going to describe how far the point estimate falls from the parameter value given in the null hypothesis. And we usually measure it by standard errors between the point estimate and the parameter. In other words, how many standard deviations of the sampling distribution. Remember, we found that by p or p hat times 1 minus p or p hat over n. Take the square root. Doing proportions. When we're doing means, we found it by sigma or s over the square root of n. So, the first thing is we do some summary of evidence against the null hypothesis. We assume that the null hypothesis is true, and then we consider what sort of values we go for the test statistics, presuming the null hypothesis is true. For the test statistic, we say how far out in the tail. So we're looking at the two tails in this, one or the other or both. We say how far away is that basically from the probability of our point estimate. And this probability is called a p-value, capital P. So the smaller it is, the stronger the evidence against the null hypothesis, which means there's more chance that our alternative hypothesis is true. So here we see it done as a picture. In the middle at the bottom you see a little dot. That's the expected value of the test statistic if the null hypothesis were true. The observed value, you can't see a dot, but it's where the blue and the white regions meet. And then we actually calculate the area of that blue section, and that's the probability. And I've got a nice question down here, which gives more a stronger evidence against the null hypothesis, a p-value of 0.20 or a 0.01. 0.20 means it happens 20% of the time that you get in the air. 0.01 means it happens 1% of the time. So that's stronger evidence to reject the null hypothesis, saying, well, if that were true, this would only happen 1% of the time, which is pretty unlikely. So the p-value is probability test statistic equals the observed value, or value even more extreme. You calculate by presuming the null hypothesis is true. It basically gives you your center, for your sampling distribution. You're saying this is what would really be true. The smaller the p-value, the stronger the evidence the data provides against the null hypothesis. So small p-values are what you're looking for, but you may not get them. Conclusion, you look at the p-value and you interpret what it says about the question that motivated you actually giving the test. So you might have to make a decision about how valid the null hypothesis was. And we're going to stop here, and in the next examples we'll actually go into how we do this.